You ever just had one of those radios when you opened it up, you went, oh my God, what did I get myself into? Well, I had not just this one, but actually 3 radios. The first one wasn't too bad, but 2 of them were, ugh, and this is one of them. So customers sent in 3 radios. Apparently had been taken to a truck stop CB shop. Now, for starters, truck stop CB shops. I don't want to do a generalized statement about them, because I'm sure there's some, CB shops located at truck stops that are perfectly reputable shops, do high quality work, honest people making an honest living. No doubt in my mind. But unfortunately, in my experience, a large majority of those shops are hack shops. That's what this radio went to, apparently, was a hack shop. I'm not really sure what the radios were sent to the hack shop for, but I can see what has been hacked. Because apparently the customer got them back and they just didn't work. So, the other one wasn't too bad. It had some... Of course, all the limiters had been removed. The common first things that everybody does to a radio is turn them into a absolute frequency spectrum splattering piece of junk. They remove all the limiters, ALC and AMC. Like I always tell people, it looks good on a watt meter. It sounds like crap on air, and all of your newfound power is not on channel. It's doing you no good. This radio was the other one was no exception, neither is this one. Limiters were removed, all kinds of crazy shit done. That's all been removed. But the first thing I saw when I took the covers off, same as the other radio for this customer, was it did not have a factory echo board. For some strange reason, I guess this shop likes to install brand new echo boards in radios that already have an echo board. This being a good example. So this one, after I reinstalled the limiters, removed all the power mods that I saw, everything that was the common things to look for in these, transistor down here, transistor back there, bodge at this resistor, lots of power swing mods, all that has been undone. Powered the radio up, has a carrier, but on transmit power is pretty much non-existent as far as modulation goes. And like I say, of course, this had one of these new echo boards. So what should be in this radio is this. This would have been, now this is a Northstar DX990V. So for starters, and this radio is a good example. So if you need service information, you're working on radios. First thing you need is service information. Preferably service manual with schematics, interconnect diagrams. The more service information you can get, the lot easier it can make your life. It can take you, it could take days or weeks trying to trace out stuff without without an actual schematic. But radios like this, there really isn't any service information. The brand that's actually on the front of this radio, you can see it's a Northstar. That was Cherokee. So there really is no service information on any of these radios. Now, if you ever run into that problem, first thing you should do is go to the almighty Google Monster. The Google Monster does great things for us. In this case, with the Google Monster, now I know because I work on radios, but if you're not familiar with radios with chassis and similarities and whatnot, that's where Google is really handy. You can just go on to Google, type in Northstar DX990V, and within the first couple posts, and not just this model, any radio, some of these oddball brands, you're liable to find someone has posted a question or a comment on some forum or chat room or something somewhere, and a radio tech or somebody that just knew told them what this radio actually is. So what this radio actually is a Galaxy DX990V. So the only difference between those two radios is this decal on the front. Everything else is exactly the same. So remove the 0, it's a DX99V, and change that to Galaxy. So with that information, you can then go to CB Tricks, a fantastic repository of technical information for CB radios and export black box radios like this. So That is a very well-documented radio. Full service manual with, schematics, layout diagrams, interconnect diagrams, everything you could ever want for one of those radios you can find on CB Tricks. And like I say, since this is the same exact radio on the inside, that's what we need. So I get the covers off, and it's like I say, it's just like, oh my God, I can see bare wires and just, and actually I'd fixed some of them. Like these were bare. I actually put heat shrink on those because those were almost touching. But I got into this, and then like hook it up, no modulation to speak of. So the more I get into it, the more cut wires I find. The farther I get into it, the more cut wires I find. It's just like, holy, pardon my French, but holy shit, what did somebody do to this poor thing? Now, the first problem I find is, this is the echo board that should be in this radio. Why would you replace this style echo board with something like this? This echo board in this specific radio, in the Galaxy 99V, DX990V, also connects to this little board. Now this is an earlier version setup. So this radio has echo, but it also has the additional voice noise toys. So it has the robot and crap, what the hell they call it, voice changer features. That's controlled with this little separate board here. The later versions, or the C version of this echo board, this is actually all one circuit board. It's all incorporated on the same board. Actually, I think they still make that board, that newer surface mount style board. But these old through-hole boards, it was two separate boards. So they took this out, but they left this in. And as you can see, there's lots of wires hanging out there. So it's only partially connected. The switch, I've taken the control out. So this apparently is I guess the control that came with this echo board. So they replaced that. But if you look down in at that echo voice changer robot switch, there's a cut-off coax cable there. Now this isn't coax like RF. There's actually two center conductors in that with a shield. There's an audio in and out. Same thing with this board. There's an audio in and out and then a shield. But yeah, one of those is cut off. This one here actually is the other wire down here. But yeah, this one just whacked off along with, let's see if I get my finger in there, you can see there's all kinds of whacked off wires down in here. What in God's name was somebody trying to do here? So I get to looking more cut wires. There's other noise toys in here. This thing's only half connected. There's bodges everywhere, just melted wires. Like I say, this is one of those radios you just look at and go, oh my God, what did I get myself into? The other one was bad, but it was nowhere close to as bad as this one. Luckily, that other radio didn't have this multi-boarded echo noise feature like this radio has, which is somewhere along the line. They just completely screwed this up. Like I say, for starters, why are they replacing them? I seriously doubt this customer had a pile of radios that worked perfectly fine, but the echo didn't work in all of them, and changed out to this new echo board, which is just a standard echo board. It has no fancy features. It's just delay and level, or actually the controls here. There's no fancy features. So it's been degraded. Just charging the customer for shit they don't need, apparently. But even if some of this is wrong, if stuff doesn't work right, why do I have a tiny, and I mean when I say tiny, we're talking this thing doesn't even really have 1% modulation. It can barely even, it's barely even noticeable on an oscilloscope. So I get to looking. So when you work on something like this, which is an absolute disaster, the first thing you need two things you need: an interconnect diagram and the schematic. Between those two, a lot of times you can solve a lot of problems. Even if you don't know anything about electronics. Even without the schematic, if you're not that good with electronics, if you can just follow wires and look at a picture, a lot of times you might be able to solve your problem. This radio is no different from what I'm seeing. So we've got all these other wires here. Now, for starters, like I say, I've had to install some heat shrink tubing because some of this shit was so close together. This is the audio in and out off the mic gain. They were so close together, almost shorting. Other stuff just doesn't have anything on it, all these other bare wires. But I guess they had some heat shrink tubing to put on these three. Why didn't they use it elsewhere? Lord only knows. So, but then again, this could have been done, and that's another problem you run into. Radios that have had multiple sets of hands in them. It's just gone from shop to shop to shop to shop. And every shop does their, more butchery to it. Maybe one shop had heat shrink tubing and the other guy didn't. But, so, even if you don't fully understand electronics, can't read a schematic, if you can look at a picture with something like this, you can probably diagnose the problem with nothing but pictures. So the picture that you want is the interconnect diagram. So what you want to look at is how stuff is actually connected. So the important thing to remember here is we have a microphone jack, echo board, and the radio. Try and think of those as three separate things in this case. Now, we don't need the echo board for the radio to work. The only thing the echo board does is, honestly, to me, make most people sound like unintelligible crap on air because they have the levels turned up so high. But it's not really needed. So the mic jack basically just continues through the echo board. The audio is processed on an echo board. But in general, you can just consider that if you were to completely remove the echo board, you could hook the mic jack up to the radio. And in this case, that's these two plugs right here. Like I say, I actually have one of the original echo boards that would fit in this radio. So you have the audio, or your input into this jack from the mic jack. As you can see, there's the mic jack, plug right there. And then the other jack goes out down to the radio. Now what's on these three wires is there's a ground, there's transmit switching, and there's audio. These radios do not need a microphone plugged into them, so you have sound coming out of your speakers. They don't actually have a receive switching line. They're just switching the transmit. But if you were, in general, I guess the easiest thing to say would be if you were to disconnect this, basically take the echo, all of the echo functions out, just connect those two plugs together, the radio would work just fine without echo. So the first thing I want to do is, troubleshooting a problem like this, is basically trace out these wires. Now we don't have the original board in there, but we can still look at this diagram and we can see we have a ground, the transmit, and audio line comes into the echo board, and then the same exact thing leaves and goes down to the main board. You actually, if you look right there, you can even see they're marked. Transmit at the top, G in the middle, that's for the ground, and then the bottom one is mic for the audio. So we should see audio and transmit lines running between here, the echo board, and down to the main board. So actually, now that I say that, this makes even less sense. Oh my God, it just dawned on me. This makes even less sense now what this person did. Wow, this is a screw up on top of a screw up. Microphone jack. First problem I see here. Lots of wires bodged on the back. Now, there are additional noise toys in here. It's a little noise toy board of some sort. So it's not uncommon to see a wire running from that to pick up like a transmit line, so it knows when you unkey the microphone, it can then play its sound or whatever it does. Grounds and lots of other things. But what is? Well, that one actually broke off. That was actually attached. Some of these wires, that's another problem. The wires so poorly soldered on here. These wires are now just snapping off of it. But most of your mic jacks that have these little boards on the back, they're going to have capacitors and little chokes on here, little RF chokes. Well, they're trying to help get RF energy that might be picked up through your mic cord. It goes out, RF power from your antenna gets broadcast. You don't want your mic cord to be a gigantic antenna with that RF getting back into the radio through the audio circuit, and can cause lots of weird feedback squeals. So they'll have some filtering on these little boards. Well, apparently that's been bypassed, because this pin should be audio. It goes through down here. Now there's a cap here, a little bypass cap to help shunt that any RF energy to ground, but it also has a little RF choke down here, so a piece of wire with a ferrite bead on it. So the audio should come out that pin, go to that trace right there, the one on the left, go through that little choke, come out down here, and go to the other pin. Well, if we look on the other side of the board here, it's an empty hole. So for some reason they've disconnected the audio there. They should not have. That should still be in circuit. They just bodged a wire on the back. Now, the problems here are that I've just noticed is, actually the audio is hooked up in two places. They have the audio here running straight down, okay? See that yellow wire, pin 2, audio. It goes straight down to the main circuit board. But it also has two other... I'm just lost. Biggest problem isn't actually that. The biggest problem is, if you look at this diagram, transmit is the terminal at the top, the audio is the terminal at the bottom there. So facing me, that should be the audio this direction, and the transmit, that little plug right there, it sits at an... You can't even see that in the camera, can you? The little plug. Get my big meat paw out of the way. Grab something here to... You can see that plug right there. Well, if I actually trace those wires out, what they have hooked up here, they have the audio hooked up to the rear terminal. Darn it, try and grab it here. See that? That yellow wire? It's at the back of the connector. What's at the back of the connector? That's the transmit switching circuit. They have the audio hooked up to the transmit switching circuit, and the transmit switching circuit hooked up to the audio. What the... Yeah, somebody has bodged this so bad. I mean, look at this. Just wires patched. Really? A patch on a patch? I mean... sloppy, sloppy, sloppy. You just have to sit back in awe sometimes, looking at stuff like this, and thinking to yourself, what in God's name was going through somebody's head when they did this? I don't know. I just want to put somebody's neck in there and squeeze really hard sometimes. So, if you ever get a radio like this that's been through the local hack shop, and they've had at it with their meat cleaver for a while, like apparently someone has with this one. Like I say, if you can find, this is a very important document for trying to troubleshoot this with no test equipment. Just like I say, just try tracing out the wires. Does it look like they hooked up the stuff right? Especially if you sent somebody a working radio and you get it back and it's not working and they can't figure out, the person that did the work can't figure out what the hell it's working. This is actually a very important document, this interconnect diagram. It shows everything that hooks up externally to the main circuit board here, how it should be hooked up. So yeah, I need to, for starters, get the audio hooked up to audio, transmit switching to transmit switching. Actually, I just need to disconnect all of these wires and reattach them properly through the chokes like they're supposed to be, which that makes even less sense to me. Why would you eliminate filtering? That's there to prevent RF energy from getting into your audio circuit. They just bypassed it. We'll just bodge wires on here. So yeah, that's mainly the point of this video. If you get a hack job like this, lay everything out. It's the best thing to do. Disconnect all the plug. Actually, there's another part missing out of this radio. That's this module here. This is the frequency counter module. I needed to get it out of the way so it's not flopping around so I could get down here and see all of this crap. But yeah, I need to start over from scratch and disconnect everything. Just hook the mic jack up straight down to the circuit board. Test it. If that works, then I can install the echo board the way that it should be. And this just half removing stuff and with not speechless. Just don't know What are people thinking? These wires, like I say, I just can't believe, like I say, that black heat shrink tubing on there, I put that there because that's how close together those wires were when I took the covers off. How do they expect those two audio lines not to short together without heat shrink tubing on them? No, not even any black tape. No effort whatsoever. This just come up and bam, short out against the cover. I mean, other wires. There's cut wires everywhere in this thing. Matter of fact, I don't even know what the hell that is yet. Actually, that probably goes to this. There's another orange wire there. That's probably that. That's probably the other end of that one. I'll have to trace that out. But man, so yeah, if you get something like this, check the interconnect diagram. Now, if you can read a schematic, that's fantastic because that's actually two very valuable tools. Is using these together because you can trace out a wire, see where it hooks up on the board. Then you can trace out on the board and see, okay, that wire, yes, that does go, like let's say in the case of transmit switching, that that's going to go to these two diodes right here. Get a pointer. The transmit line is going to hook up right here. This is basically the input for your transmit switching circuit because that's operated by this dual op-amp IC right here. That's your receive transmit switching and your microphone amplifier. But you can trace that out. So you can see wire colors, what's connector goes where, what's connected to what it does. It's labeled here on here, and then you can trace out follow from that over to here and actually see which components are wires supposed to be connected to. But yeah, this is ridiculous. How somebody can not only do this, but charge somebody money to do this. If they did it to their own radio, that's one thing. That's they're only screwing themselves. But this is, man, I just... Oh, one other gripe before I stop. People, if you have one of these export radios, you see this little thing back here? It's called the mirror board. They call it a mirror because it's kind of what it looks like. It's shiny, it's almost reflective. But you have to remove this little board when you adjust the bias on the driver and final transistors or MOSFETs, depends on what you have. So this needs to be removed. If you go soldering that board on both sides to all those terminals, how in the hell are you ever supposed to get that out when you do a transceiver alignment? You can't. Yeah, well, it was. I had to get, you can see all the solder blobs on there and all cleaned off. They had every terminal, all three of those terminals on both sides, not just one side, but both sides of the board soldered in there. Now, a lot of people say, oh man, but yes, I don't want that to become a bad connection and possibly cause me problems. And I'll have low output power. I'm going to get a better connection with a solder joint. Hooey. Bunch of hooey. If these terminals are properly tensioned, I should be able to pick up this radio from the backside with that board. See that? That board's not coming out. I got to hold the radio down to get that damn thing out. It's not going anywhere. That's the only way I can get it out. I have to hold down on the back of the radio. There should be a lot of frictional tension there. It's real simple. If the board's loose and comes out, just take a pair of needle nose pliers and gently squeeze those little terminals back together. You'll find that it holds, like in the case of this one, it holds just fine. So now, when I do the transceiver alignment, once I get this bird nest butchery figured out and can actually get to a point where I can do the alignment, I'll actually be able to remove this to be able to install an amp meter there in series so I can actually adjust the bias and driver, because the way this thing was when I got it with all those terminals soldered down, that was impossible. Another thing, I'm assuming the drivers and finals have been out of this at some point in time. I know you can't, I'm not going to ask you to look for it, but you'll never see it in the camera view here. But there's a bias, you see this little tab? Okay, it's kind of separated by the ceramic insulator here, so you've got the final transistors, driver transistor here. They have a little ceramic washer here. And then there's a little board that sits right on top of those, and then the nut goes on. That little board is a bias diode. That bias diode is supposed to be attached to this little board, which is touching the transistor, or MOSFET, depending on what case. Like I say, transistors, but there's a diode there. That's the bias diode. That is supposed to touch that because that's what it's sensing is temperature. Notice, see that? There's a gap, big gap. It's not attached. Does that one look like it's attached? I know you can't see in the camera, but look at that. I can get my tweezers right in behind there. It's not attached. That one looks like it's still glued on. No, I'm wrong. It's not attached either. Yeah, see that? It just pulls right out. Now that one could have fooled anybody because the glue just fell off of it now. But yeah, it was clearly, it looked like it was touching. But these two had a gap like that big between the diode and that board. So that means somebody probably had this apart, may have put new finals in it at some time, reinstalled it, and just left it sitting like that. Really? People just take absolutely no pride in their work. Like I say, if you're doing it to your own radio, the only person you're screwing is yourself. So, honestly, who cares? But if you're doing this kind of shit and you're charging somebody money to do it, shame on you. That should be the title of this video, probably. Shame. Shame, shame. Ugh. Well, I do believe I got her all figured out finally. Wow. I don't know what to say other than that. So I was correct. They had the audio line. So pin 2 on this microphone jack was connected to where it should be, to where the ground for the microphone jack should hook up to the board, and where the ground should hook up to the board down here, and vice versa. So the audio and ground were basically switched. They had the wires flipped over. I don't know. Yeah, so, and then, to make matters even worse, they had the input and the output wrong on this Echo board. Because once I got that done, I just took this noise toy out, to get it completely removed from the circuit, which, I'll get into that in a second. Try and get her back to halfway original condition, least amount of crap there, stuff attached to the radio, simplifies troubleshooting. But, I got this second, I was like, man, the audio just sounds horrible. it's the echo, not really working very well. So I just really quick took one of these cut off piece of lead and jumpered the input and the output. Had audio. I even had echo. It wasn't working great because, like I say, I had it jumpered, but I was actually getting some echo effect. Yeah, so you get to look a little bit more. Yeah, they had the input and the output switched. You couldn't have done much more wrong. Actually, you could, and they did. The next thing, the noise toy. So once I get all that straightened out, you'll notice there's the little board missing here. So the robot voice changer board. Of course, that's a 2-board system in the early radios like this, where nowadays they went to the single board Echo robot voice changer boards. The only reason I can figure they left that in here was, I guess they assumed you need that for talkback, because that is in your microphone circuit. It's not needed, and the robot and the voice changer don't work because it's not attached to the other board. And not only that, they had all of the wires cut off of the switch, much less. So even if it could work, it wouldn't, because all of the wires had been hacked off. So yeah, that's been removed, because, like I say, the only thing I can figure they left that in there for was so it had talkback. And like I say, it doesn't need that. The radio itself has talkback built into it. That's already designed into the radio. They just needed to remove that board and connect the correct wires. So that's what I did. So now the actual, if I get the camera down here far enough, the actual Echo robot voice changer switch is now basically a talkback switch, and that's pretty much all that it does. In the center position, it's talkback. In either the robot or voice changer, it just turns talkback off. So that's basically what it was doing before. I just switched how it works, because actually the way it was before, in robot you had talkback, in Echo you had nothing, and in voice changer you had talkback. So usually when you're using talkback, it's going to be because you want to hear what you sound like, so you can get your Echo adjusted properly. So that's why I put it in the Echo position. But so then we come to this little noise toy board. So it's a sound bite. Yeah, sound bite as in, like a logic byte. Electronics energy source, and they still make these things. Actually, they sell them on eBay. I get to looking at this little guy. Now, like I say, it's a fairly simple board. You can see there's not a lot here. They literally had all 4 wires hooked up wrong. Went in, did a little bit of checking on it, and it's not hard. I mean, the ground plane is going to be the ground. There's an electrolytic capacitor here. The other key is there's a voltage regulator. It's got a 78L05 voltage regulator on it. So, worst case scenario, if you don't know what the pinout of that is, pull down the data sheet for that, and you can find where the input voltage is on that, and the ground, and then you can trace which wires are attached to the input voltage on that and the ground, and at least find that. Yeah, they had the... I don't know how this thing didn't vaporize. Well, no, I do know how it didn't vaporize, because there are some protection. There's a few diodes in here and a blocking capacitor. So if it hadn't been for that, the people that made this board, if they didn't have this cap, that diode, and that diode in here, this thing would have vaporized the way they had it hooked up. Because they had the ground hooked to hot. They had the input, which is the white wire, which goes through this ceramic capacitor, through this then trimmer resistor to adjust the output audio level. They had that hooked up to an 8-volt switching source, not to ground, because this needs to sense ground for switching. That's why it hooks up to the transmit line on your microphone jack. No, they had it hooked up to an 8-volt voltage source. Luckily, capacitor here, so that blocked the DC, again preventing magic smoke from being emitted. They had the positive line, the blue wire, attached, I think that was to the audio on the mic jack. And they had the switching circuit, which is the brown wire, attached to receive, I think it was. I don't even remember. It was just, all 4 wires were wrong. That's basically what it comes down to. So... now, I did change the trimmer resistor on this thing, because the one... Where in the hell is it? There. Yeah, the one that was on here... Man, this thing was so sensitive. You'd go from almost no sound to blown out of your seat. There was no in-between. I don't know if somebody screwdriver... Well, they screwdrivered the rest of the radio to death, so I guess they screwdrivered this poor screwdriver adjustment to death. Let's see... Straightened up a little bit more of the wiring, got everything mounted. Now, the only thing I do have to do is I have to put that, actually it's sitting right here, a piece of heat shrink tubing, and it's going to live right here, because it does not have any mounting. That's the only thing the people that make these, I might suggest make the boards just a hair bit longer, and put a hole for a mounting tab, that way you can get a little 90-degree angle bracket and actually mount this. Might be nice. I'm not a fan of putting shit in heat shrink tubing and just let it bounce around in a radio. But that's what I'm going to have to do. I'll put it in a piece of heat shrink tubing and then probably wire tie it to this so it can't actually move. And then the heat shrink tubing will prevent it from shorting out against anything. But, and the bias diodes on the driver and the final transistors, you can see there's some white stuff on there now. That is not heatsink compound or heatsink grease. That's actually thermal glue. Now, if you ever need to get any of that, people, you don't need to spend boatloads of money. You can get some from 3M. It's like anything 3M. It's holy shit expensive. You don't need to get fancy. Just go on eBay. You get this stuff from China. It's actually, now there's lots of different brands of thermal glue and thermal adhesive on eBay. Some of them are crap. I actually spent a year or so basically testing a lot of the thermal adhesives and the thermal glues sold on eBay. I found this one, and I'm very happy with it. It works really well. It has a very short curing time. Some of them, I swear they never dried. You'd put that stuff on here and you'd come back a week later and, yeah, if you could wiggle the part around and pop it off, it would still be wet in the middle. So, yeah, this stuff has a fairly good curing time. Seems to transfer heat very well, because I've actually used this to attach heat sinks to ICs before, and works really well. But, yeah, you can pick this stuff up on eBay. Just look for this tube with the HY910. And it doesn't cost much. But, yeah, so that's what I did. Now, the diode, of course, it really should be touching that little piece of circuit board right there. So, you know, when you shove a little bit of glue down in between there, and then take something like, well, a pair of tweezers, and grab one of the wire leads that comes up off of that diode, and kind of give it a twist, like in this direction. Because what you want to do is tension that diode so it actually it's pushing in against these little pieces of, you know, circuit board material here, so it has really good contact with that. And then, of course, the glue will hold it there and help to also transfer heat. But so it's all back together now. It's had a transceiver alignment. Like I said, the board is not soldered in. So you can see I can pull that board back out again. It's the way it's supposed to be. Nice and tight, but it's not going anywhere. I don't know, like I say, I get the feeling people think there's like 20 amps of current going through that thing or something, and that's why they need to solder it for a better electrical connection. There's not. There's not that much current that really passes through that board. Trust me, those 3 terminals, because it's touching on both sides of that mirror board, it's more than enough. Now, the Echo and Robot, so let's give them a try and see what they sound like. Now, I'm going to tell you right now, if you got a kid in the room, you try and shield somebody from, I don't want to call it profanity, but almost mildly pornographic. You might want to evict them from the room for a minute, because that's the sound bite that is on this board that's in this radio. So, be forewarned. So, let's see. We've got our Echo. I've got the Roger beep turned on, and here we go.
Oh my God, that feels so good. Oh, yeah. Oh, slow down. Oh, sure, Daddy. Oh, yeah, there's my balls. Yeah, just roll them around. Oh, my. I love it when you... Uh-oh, slow down. Don't move. I'll go get you a towel.
Yeah, I'm assuming that's a soundbite from a movie or something. I have no clue, because I don't ever remember hearing that. But yeah, whatever. It works. If that's what the customer wanted in there. Obviously, because you have to order these with the soundbite already programmed on it. But yeah, there it is. Oh, and then the let me turn that off. And the Echo. Now, I will say this Echo board does have a very large range. It goes from reverb at the bottom end all the way up to an extremely long echo time at the top end. So let's turn that up the whole way. I have to turn the mic gain down so I don't get blown out of the seat. Audio 1 2 1 2. And you can make all kinds of neat sound effects if you turn the control and then turn it, or you talk. I'm almost got to stop. My God, that echoes so long. But yeah, you can even make some weird sound effects if you make a sound and then move the camera out just a hair. If you make a sound and then spin the timing control. So 1 1 1 1 1 1 1 1 1 Ow. Oh. Yeah, I'm sure kids could have fun with that. But yeah, so the Echo works as well. So there you go. There's a hack shop butchered radio put back to at least halfway some semblance of repair. Wow. Nah, this isn't the worst I've ever seen. I had to think about that for it, because trust me, I've seen some really bad ones. I was going to say this is it, but nah, actually, I have seen worse. And when I say worse, I mean people tried to put stuff in and ended up just cutting all the wires off, and when a radio gets sent to me, you end up with a pile of boards laying over here, and here's a radio over here with 40 or 50 cut wires, switches missing, and yeah, this one wasn't quite that bad, but yeah, it wasn't that great either. But yeah, so when you're doing, if you're going to do modifications like this, changing echo boards out, one of the first keys is read the instructions. I know people were prone to not reading instructions. They think they're geniuses and they can just, through osmosis or something, just touch the component to their head and they know how it's supposed to fit in a radio. But if you don't do this, well, actually, if this was done by a shop, they should have known better, but read the instructions. Even experts make mistakes. And if you have the instruction sheet sitting there while you're installing it, there's going to be a lot less chance of you screwing the installation up if you actually just follow the instructions. I mean, if you designed and made let's say the echo board, yeah, you probably don't need an instruction sheet on how to install it. But it never hurts. Just lay it there. That way, if you question halfway through, oh, damn, did I hook is that the right wire? The right wire hooked up? You can just glance over at the instruction sheet. Same thing with this. They provide a connection diagram. Now, if you work on radios for a living, you shouldn't even need, honestly, a connection diagram for this. You should be able to look at it. Regulator, that tells you the input or the voltage in the ground sources. You can look at it and tell which is the audio out. The wire color is kind of a giveaway. White is usually audio, but there's a DC blocking cap and a trimmer resistor for setting level control. And then the other one, the ground, the brown wire, that actually goes to a diode right here with the cathode going attached to that brown wire. So you know it's kind of basically looking for a ground. So, I mean, it's kind of self-explanatory if you work on radios for a living. At least I'd hope you would know that. But even if you don't, just follow the instructions. If the person that installed this thing had just looked at the instructions, it's not hard. 4 wires. I think to myself, how can you possibly screw it up? And then I see shit like this. So, there you go. There's a Northstar DX990V back up and running and ready to be put back into service.